Hello everyone, and welcome back to the Kohi Game Engine series. Today we are going to do a little bit of prep for the next feature that we're going to implement in the engine. Today we are going to take a look at a refactoring and reorganization of our view system, our render view system. And that's because we need it to be a little bit more flexible. We need to remove some of the assumptions that were being made about it, and make it so that it's a little bit more configurable, or at least a step towards being more configurable. Because one of the things we're going to eventually want to do is have the consuming application actually be able to configure those views or add additional views. And right now it's just not set up in a very flexible way to be able to accomplish that. And so we are going to make a series of changes today that are going to go ahead and put those updates in place. So before we do that, though, there are a couple of things that I noticed that actually need to be fixed. So one of the first things that we need to do is we need to actually go into our material shader. That would be the fragment shader. And we're actually we're using this constant here as a variable name. And this is actually going to break on Mac OS. And a lot of you who are following along probably found this out sort of the hard way. I did not find this out the hard way because I had actually built it off screen and had this fix in place, but for some reason it never actually made it into the video. So constant, this word constant is actually a reserved keyword in the metal shader language. So we actually can't call this constant. So what I'm going to do is I'm actually going to go ahead and just do a find and replace on this. And we'll say anything that is called constant, we are going to rename that to constant underscore f. And that is basically just going to be, I think, just a straight up find and replace on all instances of it. This is being the most important one here in calculate point light. And then, of course, in the point light struct itself. So that should go ahead and take care of that. So for any of you that ran into that issue, that is the fix for that. And again, that is because on Mac OS, Vulkan feeds into Molten VK, which is metal under the hood. So eventually those that shader code gets compiled down to a metal shader, and the keyword constant becomes an issue here. So we'll just rename that, and that will fix that issue. So that is that. So the next thing is we actually have some stuff in our shader config files that is sort of legacy and old and doesn't really need to be there anymore. We have this use instance and use local, which we used to set manually. And those things just frankly aren't needed anymore. So they haven't been needed for a while. They're not actually read by our code anymore. They're completely ignored. So we can go ahead and remove those. And as a hint of what is to come, we're going to be adding two new fields to this. So we're going to have a depth test and a depth right. These are two new configurable properties that we are going to have for our shaders. And we'll go ahead and hook this up in the shader and the renderer backend when we get to that point. But each of these are going to be configurable. So our built-in material shader is going to have depth testing, and it's also going to write to the depth buffer. So we're going to set both of those to 1 for true. And then we are also going to go ahead and set these properties in the UI shader as well. So we'll go ahead and do that here. So we're going to get rid of use instance and use local and replace that with depth test and depth right. In this case, they're both 0 because the UI shader is completely flat. So it does not depth test, and it also does not write to the depth buffer. So both of those are set to 0 on that. And then the skybox is actually going to be the same way. So we can get rid of use instance and use local and replace that with depth test and depth right equals 0 in both of those instances. So that is that. One other thing is I actually found a bug in our free list. And so I wanted to go ahead and fix that in here. So basically, when we are performing our free, there is an error in the logic. Let me just find the section here. So when we are looking for basically an offset or a node with the offset, basically what we should be looking for is, instead of checking to see if the offset is equal to offset, we should be looking for the offset plus the node size to see if that's equal to it. And then instead of saying, you know, we can just append it to this one, we're going to say that we should append to the right of this node, right? So if we actually do a check when we're freeing, and we already find a node, remember this is a free list of sections that are already free. So if we actually have an exact match, that's actually a problem, right? So this should only, this case here should only occur if we actually find a node who, once you navigate to the end of that node's offset plus size, is equal to our offset. So if we do have an exact match, we actually need to treat that as an error, because that means that we're trying to free a block that has already been freed. So I'm adding a new case in here to say if those two things are equal, we are going to say we are attempting to free an already freed block of memory at the offset, and then go ahead and print the offset. And of course, that would cause us to return false to indicate a failure. Likewise, there's also a case that we did not catch. And so that is going to go all the way, let's see, right here at the end. And that is if we are on the last node, and the last node's offset is the offset plus size. If the last node's offset is offset plus size is less than the free offset, then a new node is required. In other words, if we've gotten to the last node in the list, but that's not far enough along, and we're trying to free something beyond that, then we actually have to create a new node and append that to the end of the list. So this just catches that individual case there. So that is the fix for the free list that we need for now. So the next thing that I think probably we'll go ahead and do is we're going to put in some additional events. So in fact, do I want to do the events first? Yeah, I think I'll go ahead and do that since that's in here, and we'll sort of explain it a little bit afterwards. So I'm going to go to event.h, and right here after the event code debug for, we're actually going to add in two new events rather. So we have event code object hover ID changed. That is a precursor of the feature to come. Just to give you guys a little bit of preview of what we're actually preparing for. So I'm not going to explain that now, but we will come back to that. So we have that, but then we also have the event code default render target refresh required. So this is going to basically be resized on any sort of event where we need to regenerate our render targets, i.e. a window resize. And this is going to allow us to handle this in a more decoupled way than we're currently handling it. So again, that will become clear as we jump more into things. Okay, so I think probably the next thing that we're going to want to do is, let's see, we're probably going to want to add some type information. So there are some changes to some of our types. You know what, actually, I want to do one more thing first. So there is also something I want to add to our dynamic allocator. And that is to be able to basically obtain the internal size of a header, right? that the dynamic allocator uses. And this is purely for testing purposes. So it's not really something that we have to use outside of that, but we do need it. And that is because the reason this is coming up is because I actually found a bug in our dynamic allocator as well. So I had written some unit tests to sort of get to the bottom of that, and along the way, I said, hey, we should probably go ahead and include some way to get what that header size is actually going to be. So here's the function for that. That is just the size of an alloc header plus the k-size storage. And the bug itself is actually one that kind of was pretty well hidden. So basically, when we are allocating, right in here, when we go ahead and get the free list block, we are getting the first of all the base pointer, which is fine, and then we're getting the aligned block offset, and we're saying get aligned of the pointer plus the base offset. So we're taking this base offset here, which is returned to us by this free list allocate block, which is already used in the pointer here. We're adding it again here, which is actually completely wrong. And so I want to make a couple changes here just to kind of clean this up and actually fix that bug. So before we do any of that, I want to go ahead and replace our line here for required size with 3 lines of code, just to kind of split this out, make it a little bit more readable so that we can reuse some of these things. So the next portion of this is basically a deletion of this base offset. So there's that, right? So as we're debugging, this just basically improves our debuggability. So it just makes it a little bit easier to understand what's going on here. So that fixes that bug, and that's actually all we should need to do for our dynamic allocator. There is actually one additional bug that we need to fix in the platform Mac OS, and I do understand that we're not going to be able to test that because we're on Linux right now, but there actually is. Let's see, where is that? I think it's right around here somewhere. So our mouse move. The mouse move does not actually take into account the content scale. So remember when we were talking about high fidelity displays, that it's essentially a device pixel ratio of like how dense the pixels are on screen. And because we are using that to determine what the backing size of a swap chain image is, we also need to scale mouse input by that. And then on macOS, we also have to invert the Y axis because the origin on macOS's UI is the bottom left, which would be fine if we were expecting that, but everywhere else it's the top left. So what we're going to do here is basically just add a couple lines of code in between here, where we go ahead and we get the window size. We then scale the X coordinate by the content scale. And then we take the Y coordinate, we scale it by the content scale, and then subtract that from the window height. And then we have our X and Y here. And then all we do is, instead of using these things directly, we just pass X and Y. Oops, that should be a comma. Okay. And that will fix that bug, because that is going to be an issue for us. Again, little hint as to what's coming next. Okay. So the next thing that I think makes the most sense to change is probably going to be our, I'm thinking our generic types. So yeah, let's go to render types, INL. And we're going to go all the way to the top. And we have here our built-in shader names. So we have one for the skybox, one for the material, one for the UI. We don't really want to use these things anymore. These shaders should ultimately be owned by the view that's using them. And that's not always going to be the case, but it's going to be the case at least for these guys. So I'm going to go ahead and remove these defines because we are going to be shifting that elsewhere. We are also going to be modifying some of our types in here. So our geometry render data, we are going to be adding something called a unique ID to that, so that every geometry render data has a unique ID. That is so that we can identify geometries individually in a way that is useful in the renderer later on. Again, it's another hint of things to come. If you guys, any of you guys have written renderers before, or probably know where I'm going with this, but I'm not going to let the cat out of the bag yet. And then we have here the right after the render debug view mode, we are going to put in basically a series of enums and structures. So right before our render target here, go ahead and just paste these in. And so this goes into the configurability of our views as well as our render targets. So we want these things to be more flexible, more configurable. And so what we've done is we've defined some target attachment types. So we have color, depth, and stencil here as the different attachment types for a render target. We have the attachment source, which right now is either default or view. And basically what that means is default will obtain the render target attachment from the appropriate backend resource in the renderer. So for example, if the attachment type is depth, it will go ahead and obtain the depth image. If it is color, it will go ahead and obtain one of these swap chain images. And then if it's view, then that means that the view is actually responsible for standing up those images for those attachment types on its own. So this gives us a way to say, keep the default behavior that we have now, or be able to sort of override that in our own custom views. So next we have a render target attachment load operation, and this looks very much like the backend load operations that Vulkan uses for attachments. So in this case, we have don't care or load. Should be pretty self-explanatory as to what those are. So basically, if we have an attachment that was used in a previous render pass and we need to load its contents, we'd use this one. Otherwise, we use that one. Store operation is either we store it when we're done or we don't care. Pretty self-explanatory, I feel like, as well. The render target attachment config. This is a configuration structure for a render target attachment. So those are going to be configurable as well. So we have the type, the source, the load operation, and the store operation, and then whether or not we're going to be presenting it after the render pass is complete. And the presentation basically says, does this need to be placed into sort of a presentation layout so that it can go be presented by the swap chain. So that's just a simple Boolean for right now. We also have render target config. So this gives us how many attachments we're going to be having for a particular render target, and then an array of those attachments. And again, this is config, so it's basically an array of these guys here. And then we have the render target attachment itself. So that has the type, source, load operation, store operation, and present after, as well as a pointer to the texture to be used as the actual attachment. So that is those. Next, on our render target, we actually have a few changes here. So this sync to window size, that's going to go away. We weren't using it anyway. And instead of us having attachments as a pointer to an array of pointers to textures, this is basically going to be an array of attachments. So we're going to replace this texture double pointer here with render target attachment, right? So it's just going to be an array of those things, and those are going to be owned by the render target, right? So they're no longer going to be an array of pointers. Render pass clear flag. One thing is I just noticed a misspelling here, so we'll go ahead and fix that. The render pass config, we are also going to be changing up. So before we had this next name and previous name, because I was thinking about going a different way with the configuration there. We're not going to do that anymore. We're going to have more than enough information in our config to not need those. So we're going to go ahead and get rid of those. And so that will leave name. And then we are going to be adding after that depth and stencil, right? And those are going to basically be the clear values that are going to be used. And then after the clear flags here, we are going to be using, we're going to have a render target count and then an array, sorry, not an array, a config for that particular target, right? So every render pass has obviously render targets. And then this render target config is actually just a flat single object that of course has attachment counts and the attachments, right? So we only actually need one render target even if there are multiple attachments for that target. Okay, so the next thing is we need to go down a little bit further here to our render backend config because there are some things here that we're no longer going to need because we are not going to do the things this way anymore. So before we had a render pass count, pass configs, and on render target refresh required. We are going to not use this callback anymore. We're going to use that event that we created instead. So all of these things are going to go bye-bye. And our config for now is just going to be the application name. Okay. And then we actually have a few utility methods that we're going to be adding. So we're going to be adding these to the renderer backend itself. So right after our end frame, we're going to add a few utilities. And those are going to be the ability to set the viewport to a rectangle, to reset the viewport, to set the scissor and reset the scissor. And so the reset basically matches to the application window for the scissor and viewport, whereas the set methods actually give you a rectangle to set those things. We're not going to use those right away, but we are going to need them. And I figured since we're kind of in here moving stuff around anyways, we might as well go ahead and get these added so that you know, we don't have to come back and do it later. The next thing is we're going to go down here a little bit further, and we have this this render pass get, which takes a render pass name and returns a pointer to a render pass. We're no longer going to be doing that, so we're not going to need that. We're going to be able to eliminate everything that deals with that as well, including the hash table and all that stuff. We don't need that stuff anymore because we are going to be handling this completely different. So that is that. We are going to need a couple of other methods since, again, we're in here. We're going to add a couple more things. So we have this create writable texture, texture resize, texture write data. We are going to be adding two more functions here. And that's the ability to read data at an offset for a particular size and then output to memory. And then also the ability to read an individual pixel from a texture. So we just pass a texture pointer, an XY, and then we get the out RGBA, and we just provide a pointer to a variable here, and that basically, a pointer to an array rather, and that basically gives us our RGBA out. So that pointer should be an array that is the size of U8 times 4, okay? And that'll give us our pixel data. And so you might be able to surmise where we're going with this, but again, you know, we'll come back to it. All right, a couple more changes. So a little bit further down, we have our render target create. Let me just find it. Let's see. It's a little bit further down. Did I miss it? Render target create. There it is. Okay. So we're going to be changing the way this works a little bit. So just like we changed before, the array of attachments is no longer going to be an array of texture pointers. This is just going to be the number of attachments, right? And so obviously that means that we are going to change this double pointer here to a single pointer, which is just going to be an array of attachments. So we'll make that change there. And then a little bit further down, we have render pass create. And this is going to require some changes here as well. So this was taking in a bunch of individual properties about having a previous pass, having a next pass. The depth and stencil, that's kind of rubbish and not really flexible. So we're actually going to replace that by just having it take a render pass config. So it's going to take a constant pointer to that, and it's going to output a render pass. So obviously that means that that all of these things can go. And then, great, there's sirens in the background. Perfect timing. Okay. So we have our config, which is a constant pointer to the configuration. That's going to be used, and then it's going to write out a render pass. We are also going to change this to a B8 for the result. So that way we can actually check the success or failure of the render pass creation. Next, we are going to make a change for the depth attachment. So the window attachment right now, we actually have a different window attachment per frame. And so we have a frame index that we take here for the window attachment, but we are not doing that for the depth attachment. And I'm going to go ahead and add that in so that we are not going to have that as a problem. Now, we may not need this going forward, but I want to build in the flexibility to have a depth attachment per frame. So basically what that means is we just need to add a index parameter and then, obviously comment it out what we're doing here. So that will still return a texture pointer. It's just at a given index now. Okay. So the next thing that we have is right below our window attachment index get, we are going to have a window attachment count get. And this is just going to return to us how many attachment counts we have for the window. So this is going to equate to how many render targets we actually need to create, or the attachments for the render target, aka how many swap chain images do we have. That is what this basically means in our case. And since we're triple buffering, in our case, most of the time that's going to be 3, unless you have a device that only double buffers. But I don't think that's going to be a problem for much of anybody. So in most cases, this is going to return 3, but we need that flexibility so that we can query for it instead of making the assumption. Okay, so a little further down after this, we have a render view pass config that just takes in the name of a render pass. This is going bye-bye. We do not need that anymore because we have our new configuration types. So with that, that's obviously going to cause a problem in our render view config. So our passes right here, this type is going to change to render pass config, right? So we just have an array of that. Nothing else really changes except the type there. So next we have the, let's see, the render view. Nothing was really changing on that, ironically. I think the only thing, nope, I misspoke, that there is actually some stuff that's going to be changing. So let's see, we have right here. So we have an array of pointers to render passes used by this view. Now, the view is actually going to wind up owning those render passes. So instead of an array of pointers, we're just going to have an array of render passes. So this is not going to be an array of pointers to them anymore. The render view is going to own the render passes. So that is that. And then the next thing is we are actually going to have to come in and add one more method. So we have after our onRender, we are going to add a call to a new method, regenerate attachment target. So we're going to take this away from sort of the renderer backend and let the generation of the render targets be up to the actual view that's going to use them, because it'll know what types to create, how many of them to create, etc. So it makes sense for the view to go ahead and handle this. So we're going to go ahead and add that there. Okay, so that is it for the renderer types. So if that gives you any idea of how much stuff we're going to be moving around, yeah. So I guess before we move on to changing around the views and all that stuff, we probably ought to I'm thinking we probably ought to make the changes to the back end, bubble those changes up to the front end, and go from there. So I think that's probably the way that I'm going to go ahead and do it. And I think probably there's a bunch of changes that we're going to have to make. So I think probably the good place to start on that is going to be Vulkan types, INO. And let's go Vulkan render pass. Okay. Because this is the first thing that we're going to have to change. So this has previous and has next pass. That's going to go away. And it's not really going to be replaced with anything. Because at least at this point, we don't really need one render pass to know about another render pass. The only thing that really needs to know that is it's managing view. So the next thing is the Vulkan swap chain has some minor changes that we need to make. So our render texture here is currently an array of pointers to render targets, or technically it's an array of pointers to textures. So instead of a array of pointers to textures, is just going to be an array of textures. So we will change that, and the swap chain will now own those render textures. And then I think the next thing that we need to do is actually we have just a pointer here to a depth texture. And this is going to remain the same type, but instead of a pointer to a depth texture, it is going to be an array of depth textures. So we're going to say an array of depth textures. One per frame. Okay. And so that's that. And then the next thing that we're going to do is we're actually going to, so if we take a quick look for a second at Vulkan pipeline.h, something that's been bothering me for a while about this is the sheer amount of properties or parameters that this function takes in. This sucks. I'm really not happy with this. So what we're going to do is we're actually going to create a configuration that can be taken in there that will contain all of the properties that we need. And so that is basically just going to be a nice struct. Let's see. Let's put that here right before the pipeline. Okay. And so that's going to look like this. Basically, it's going to take a pointer to the render pass. So this is basically almost going to be a one-to-one list with what we see in here, right? So a lot of this has just been moved over. I think it pretty much is one-to-one actually. So instead of passing in all of this stuff, now we can just pass in one of these guys and not have to set all those properties individually. All right, a little bit further down, let's see. So we have, here we go. So here's the data around the render passes. So we have this Vulkan max registered render passes, and this is for the hash table that is used to store those. We are going to get rid of that, so we can get rid of the define as well. The next thing that we want to do is we actually want to, in the Vulkan context, probably right after all the generation stuff, we want to store a viewport rectangle. And this is for those reset commands that we added. So whenever we reset the viewport or the scissor, it will reset to whatever is in here. So we just have a way to actually handle that. And then a little bit further down, we see here that we already have an error from this. So we have a render pass table block, render pass table, and registered passes. These are all going to go bye-bye because we're not going to hold those. We're not gonna hold a table for that anymore and do lookups that way, just because it's not really the responsibility of sort of the Vulkan backend to hang on to those. And then a little bit further down, we have this function pointer to on render target refresh required here. This is also going to go bye-bye because we're going to handle that with events. So we can get rid of that. And that should pretty much do it for our Vulkan types. So with that, I think I'm going to stick to the pattern actually of changing all the types first and then go back and change the code. So I'm actually going to jump to resource types real quick, and then we'll jump back to the Vulkan stuff. So we just need to make a couple small changes in here. So we have our texture flags here. So we have basically our transparency, writable, and wrapped flags. We need one more, and that is a texture flag depth. And this is just to indicate that the texture is a depth texture. And we're going to use this when creating depth textures. So should be pretty self-explanatory, I think. The next thing that we're going to do is we are going to come down here to, in fact, let me just look for mesh. Here we go. So right above the generation, we are going to have, we are going to have a unique ID for mesh. And again, we're going to need that for something that the renderer is going to be using very shortly. So I just want to get that in now. And then a little bit further down, our shaders are going to be changing a little bit. So we have, let's see, our shader config. Here we go. So before we had a render pass name in our shader config, and this is no longer actually going to be used. So we're not going to read that in anymore because the shader itself will be connected to the render pass by the view. So the shader doesn't need to actually know that information. It's going to be supplied that information by the view or whatever owns the shader itself. So as you might have guessed, since we added these properties elsewhere in our shader config files, we are going to have a Boolean for depth test and a Boolean for depth right. We probably ought to come through here. I probably ought to eventually convert this to flags instead of booleans because that's kind of a waste of space. But we don't have a lot of shaders yet. So you know what? To do convert these bools to flags. That'll just save us a little bit of space if I do it that way. Anyway. So that is it for the resource types. Not a whole heck of a lot of changes there, but something I thought that we should probably go ahead and knock out nevertheless. All right. So I actually think that is the bulk of the type changes. In fact, that might be all of it. Before we actually jump into the Vulkan stuff, I do want to jump down to our test project because I did actually mention that I found those bugs via unit tests. And this was actually because I was running some tests while I was prepping for this video is how I found the actual issue. So what I'm going to do is I'm actually going to add the tests that I used to determine or to find these particular bugs. So let's see, not memory. We want containers. We want free list tests .c. And so we actually added basically just one test to this, but that test actually added a data structure as well as a couple of utility methods. So basically we have this alloc data structure just to keep track of allocations. And then something to a utility method basically to perform an allocation and make sure that that allocation is good and matches what's expected. So that just takes the free list, the data or the alloc data basically here saying what the allocation should be, a pointer to write out the currently allocated amount, and then the total list size, and then we just validate those things. And the same for free, so we just have a version of that for free. And then basically what this does is this test performs a bunch of random allocations and frees in different orders and in different sizes, and basically runs a whole crap ton of them, basically 65,000 of them, to make sure that all of these things are allocating and freeing as correctly as possible. And running this test was actually what gave me an insight into the actual bug. So I'm not going to go through this in depth, but I do encourage you guys to have a look at this test to kind of see what it does. But basically, the crux of it is it just performs a bunch of allocations and frees at random sizes and random operations. Okay, so that is that. And I also added some tests around the dynamic allocator. And that one's a little bit more in depth, actually. So I'm going to go ahead and, again, just sort of paste this in here. And in fact, I'm actually going to... I'm going to just actually replace the entire file, I think, because basically there is a lot of changes in here. Like I added basically 500 lines of code. But we added 4 tests. So we just added some different allocator tests dealing with different alignments, randomization, and things of that nature. So we've gone ahead and really exercised this as well. And so you can see here that we've done, we have a lot of operations, we have a lot of allocations happening of different alignments and sizes. And this is really just to exercise that code and to make sure that all is well. So I've gone ahead and added those. I'm not going to step through them in detail. It should be pretty obvious what they're doing if you have a look at the code. But I did want to go ahead and get those added as well. All right. So I think the next thing that I will do is I will go ahead and jump into the Vulkan work because there is quite a lot of Vulkan stuff that actually needs to be done. So I think before I jump into the back end, I'm actually going to hop over to Vulkan image because there are a couple of methods that we're going to have to add to that. So right here, we are doing copy from buffer. We're going to add 2 new functions. So we're going to be able to copy to a buffer now, and then we're going to be able to copy a pixel to a buffer. And this is going to be used for reading image data. Okay, so it should be pretty self-explanatory how these work. One of them basically takes a range, and then the other one takes a specific X and Y position and then obtains that data. So the implementation of this, as you may have imagined, is nothing too crazy or special. Let's go to image.c. And basically, we're going to come down to right above the destroy and put this in the same place it is in the header. So the copy to buffer basically does the exact opposite of copy from buffer, using just an image sub-resource, and then copy image to buffer instead of copy buffer to image. And then the copy pixel to buffer is basically the same thing, where we copy an image to a buffer. It's just we use a sub-resource based off the X and Y. So it's actually pretty straightforward and simple to actually set this up and use it. There are a couple of other things, though, that we need to go ahead and support for upcoming changes. So when we are doing the transition layout here, we have some pretty specific layouts, transitions that are supported, and that is it. So right now we have undefined to transfer destination optimal. Then we have transfer destination optimal to shader read-only optimal. But those aren't the only ones we're going to need. We actually are going to need 2 more. So I'm going to go ahead and put those right here. And basically it's going to say we need to be able to transition from image layout transfer source optimal to shader read-only optimal. And this is for sampling an image, right? So when we're reading from an image, that's what we're going to need that for. And then we also need to be able to go from undefined to transfer source, right? So we need the ability basically to support the functions that we just added here. So those image transitions are going to support that. Okay. So I think the next thing that I'm going to do is, let's see, we have that. Let's go ahead and knock out the pipeline first, and then, because I mentioned I want to change that that function, and then we'll probably knock out the swap chain after that, and then the backend. So let's do pipeline.h. So the pipeline create, basically we are going to be eliminating all of these except basically the context and pipeline. So we can get rid of those, and then we're going to be adding config. So we're going to have the config right here in the center. And that means the same for the properties. So basically we're going to get rid of all of this and replace it with config. Right, a constant pointer rather to a pipeline config. So that simplifies that. In fact, I might even be able to fit this on one line now. Yep. So there's that change. And then we just need to obviously go into the pipeline C and make that change there as well. So that is basically going to involve a couple changes. Actually, the first thing we're going to have to do, though, is we actually do need a include at the top. Right here looks good to the shader system, because we are going to have to get some information from that. But again, we're going to get rid of everything between context and out pipeline and replace that with a config. Again, I think I can get this on one line, so let's go ahead and do that. And basically now what we're going to do is go through and just say config arrow on all this stuff, right? And I think for the most part that's actually all we have to do, because it's all part of that configuration option now, or argument rather. So this depth test enabled doesn't exist as a Boolean anymore, so that's actually going to be config shader flags. And we're going to check that to see if shader flag depth. Wait a minute. Shader flag depth. Why is that not appearing for me? Shader flag depth test. I'll bet I didn't add the enumeration to that. In fact, I'm pretty sure I didn't, because that's actually going to exist in the shader system, which is what we need our include for. So I'll have to come back to that. But basically, instead of having a Boolean there, we're just going to do a flag check on the shader flag. And then likewise, we are going to not assume that we're going to be writing to the depth buffer all the time. However, we want to do a check again against those flags to see if depth right is enabled. So this is actually going to be something we have to go and fix in the shader system. But basically, if the depth right is enabled, then we go ahead and set this to true. Otherwise, it's going to be 0 because it's getting zeroed out here, so it'll be false. So the only time that it's valid to set depth right enable to true is if depth test enable is also true, per the Vulkan spec. So it makes sense to sort of nest that check in that manner. All right, so going down, just ignoring those two errors for now, because we'll have to come back to that. We're going to continue adding our arrows, because that is most of what we are dealing with here. Okay. One more here. And a couple more here. And here, and here. Stage count, stages. This depth test enabled is actually going to be the same test that we had here. So I'm just going to copy this guy. And let's see, right here. Okay. So we'll go ahead and undo that. In fact, just to make sure that handle that correctly, I'm going to surround that in parentheses. And then this should be config, config arrow. I think that's actually it. Oh, yeah, okay. So that's it for the pipeline, right? Not crazy amount of changes, but it makes things a little bit more flexible there. All right, so the next thing is going to be the swap chain. So I'll start in the H file as we typically do. And actually, come to think of it, there aren't changes in the H file. It's only in the C file that we have changes. So that actually simplifies things a little bit. All right, so up here, within destroy, we're getting an error here because it's talking about the render textures and freeing this array, size of Vulkan image, and this is basically saying it needs to be a pointer to a type. We're not actually going to be doing this anymore. This is not necessary, so we can just delete that entirely. We need to also come down here to, let's see, our acquire next image index. There is a, was it in here? No, it should be, wasn't there, that was the issue. There's a cast in here. I think it is, yeah, here it is. Okay, so we are creating the render textures array, but right now this is creating it as a texture double pointer, and it should just be an array of textures, right? Instead of an array of pointers to textures, which means we most importantly need to change this to just be size of texture, not size of texture pointer. This will cause massive problems if you don't change that. So make sure that you definitely make that change, because it will cause nasty bugs. Because the size of a texture pointer is only 8 bytes versus the size of a texture, which is much larger than that. So make sure you do that one. And then our wrap internal here is actually going to require some additional changes as well. Although we haven't actually made the changes to this yet. So I'm going to change this to what it should be, because we're actually going to have to change the way that this function works. because we are going to be, we're basically not going to be returning a texture pointer here anymore. Let me think about this for a second. So yeah, we should just be able to get rid of this internal data because we don't need that anymore. And we should be able to also get rid of that and just call texture system wrap internal. And then right below that, we are going to, instead of saying if not swap chain render textures sub I, oh, right. We have to actually, yeah, I got lost for a second there. So we do need the internal data. We don't want to delete that there. We do need to instead take the address of swap chain render textures sub I. So the change here is instead of returning a texture pointer here, we are going to take a pointer to a texture, right? And that is what that is going to be looking at. And then here, we're going to be checking for the existence of internal data instead of just the texture itself, because the texture itself is no longer a pointer. It is just a flat texture, okay? So again, we are going to have an error here until we actually get back to the texture system to make that update. Okay, so the next thing is the texture system resize. We now need to take the address of render textures sub I. So that's just that. A little bit further down, we have the image here. So this just needs to be changed from a arrow to a dot because it's no longer a pointer. This is also an arrow to a dot because it's no longer a pointer. And then, let's see. So this entire section here where we have we create the depth image in its view and then wrap it in a texture. We are going to be doing that, but we are going to essentially be wrapping it in a for loop. But before we do that, we need to come right here and say, if we do not have the array for the depth textures to be held, we need to allocate that, right? So we'll go ahead and allocate that. And then we are going to basically surround this section here with a loop to create all of our depth textures because we have multiples of them now, not just one. So we'll change that to a loop. And then I guess all we'll really have to do here is this should be Vulkan image instead of texture. So I think that was a bug. And then when we go to create the texture, that should be fine. We're outputting to the image, that should be fine. This needs to be depth textures. In fact, this gets removed because this is that wrap internal. We're going to be changing the way that works. So what we really need to do is after image, we need to present the address of depth textures sub I. Okay, and again, that's going to throw an error right now just because we haven't changed that function yet. Okay, so next, in the destroy, we are actually going to take this section here where we have Vulkan image destroy. We are going to get rid of the free because that is rubbish. And after our device wait idle, we are actually going to basically wrap the image destruction in a loop, right? So we're going to go through our depth, or our swap chain images. No, our depth, but for the swap chain image count, rather. So we're going to be going through and destroying those images one by one. So we'll call this against depth textures sub I. And then that needs to be a dot instead of an arrow because it is no longer a pointer. And then this needs to be depth textures sub I dot. Internal data is zeroed out, so we zero that out. And then this actually should just be a dot instead of an arrow. And I believe that actually resolves the issues in the swap chain for now. Okay, so that is the swap chain. Next, I guess let's go ahead and let's tackle the backend. So Vulkan backend H. So we're going to be adding some things here. So the first thing that we're going to do is go right after end frame here. We're going to add our Vulkan version of the viewport set, reset, scissor set, and reset. So we'll add those. We're also going to get rid of the render pass getter by name because we don't need that anymore. We are going to come down a little bit further, and after the texture write data, we're going to insert our Vulkan versions of read data and read pixel. So we have those. And then the render pass create, we are going to be changing to, let's see, here we go. We're going to be changing the return type to B8 to indicate success or failure. And then we're going to be replacing all these parameters with just these two. So a pointer to the config and the out render pass. The next thing is on the Vulkan render target create. Instead of taking a texture double pointer, once again, we are going to take a render target attachment pointer, or an array of those things. So we're just going to change that up real quick. And then come down here to the depth attachment get. We're going to add an index to that. And then we're going to add something here to also obtain the window attachment count. And that is going to be it for the backend, at least in the H file. So we'll go to Vulkan backend C. And I'm not going to lie, there's going to be quite a lot of changes here too. So the first thing we're going to do is all the way at the top, right below K memory, we're going to add event because we're going to need to kick off an event for the views to refresh their render targets. And then we're going to come down here, probably where this first error is, I'm guessing, a little bit further down. So we're setting this context on render target refresh required to the config on render refresh required. Neither of those exist anymore, so we can completely get rid of that. And then the next thing that we're going to do is further down in the backend initialize, we have this whole slew of errors here, right here. So this is where we are holding the registered render passes. So we're basically going to take from here all of this render pass creation code all the way up to just before our create command buffers, and we're going to get rid of it because we're not going to be creating those render passes here any longer. The backend is not going to be managing or owning them or doing anything with them except simply executing them. Likewise, in the shutdown, we are going to remove the code for render passes because, again, it's not owned by the backend, so it shouldn't be destroying them either. And we're going to make a couple of small changes to the begin frame. So let me just go to begin frame. And let's see, a little bit further down, we are creating the dynamic state for the scissor and setting the scissor in viewport. We're actually going to have methods to do this for us. So what we're going to do is we are going to completely eliminate these guys. And instead, we're going to call our new methods. So we're going to set a context viewport rect, basically the same thing we had before. So 0 frame buffer height, frame buffer width, negative frame buffer height, and then call our new Vulkan render viewport set. And then right below that, we are going to do the same for our scissor. So we'll set up the scissor rectangle, 0, 0 width height, and then our scissor set, right? So we might as well just use those new methods that we've set up. Speaking of those new methods, we need to go ahead and implement them, and they are pretty straightforward. They're basically going to be what we removed from here. So I think right before our render pass begin is a good place for those. So we're going to basically put those in here. And all they're going to do is take the rectangle, build a VK viewport out of it. And then it will go ahead and grab a command buffer for that. So the graphics command buffer in this case, and then just set the command set viewport. The reset will basically call that as well, except just passing the saved viewport rect. So if we call this passing some other rectangle, notice that it does not actually set the viewport rectangle, right? So this is this does not override the context viewport rectangle, which is considered our default. That's only changed on a window resize or some event like that. So this basically just sets it in the Vulkan state, but not our context state. So this is a way to reset that. The scissor works the exact same way. Okay. So our render pass begin needs some minor tweaks as well. So right where we are doing our setting up our clear value count. So in our, let's see. Let's see. So we are doing right where we're doing the stencil buffer, the depth and stencil. So depth and stencil buffer. So we have if do clear depth here, and then we do the depth stencil. We do not have an else case for this. So what we're going to actually do in this case is if we do not clear the depth, which means we also don't clear the stencil in this case, then we're basically going to loop through our attachments. If any of the attachments are of type depth, we're going to go ahead and we're going to add to the clear count, but we're not going to copy over the data, right? So this depth stencil, depth value, and stencil value, we're not going to bother copying those things, right? We still need to increment this if we have somewhere where we're not clearing the depth, where we're just reading it in, for example. But we don't necessarily want to clear it. So we just ignore that essentially. All right, next we have render pass end, that's fine. Here's our render pass get, we are gonna remove that. Okay, let's see. The next thing that we need to do is probably in our, well, wherever this next error is actually is probably the next one. So recreate swap chain. So there is some work that needs to be done here. Basically, we're going to say, instead of telling the renderer that a refresh is required, right, this is using that callback that we had set up. We're not going to use that. Instead, we are going to go ahead and fire off an event instead, right? So we're just going to use that new code that we set, saying, hey, anybody that's concerned or listening for this, we have an event code, default render target refresh required. So it's saying, hey, anybody that needs to refresh it, refresh your render targets now. Okay, and that just keeps us from having to hook into anything aside from the event. Okay, so the next thing that we need to do is look at create writable for our texture, because we're going to have to make some changes here. So basically what we're going to do is our Vulkan image create is going to look a little bit different. So the first thing that we can do is we can get rid of this lots of assumptions, right? Because we actually want to take a look at some of the properties that we're passing in and use those instead. So we're actually going to take and get rid of this whole Vulkan image create. And we're actually going to instead sort of build out some of our options for this and then call Vulkan image create. So we're going to create the usage aspect and image format depending on the texture flags. So if it's a depth texture, we're going to set the usage to be a depth stencil attachment. its aspect to be depth bit. And then its format to obviously be the device's depth format. Otherwise, it's going to basically be transfer source, a transfer destination. It's also going to be used as a sample and as a color attachment, okay? And then our aspect is basically just going to be color, and we're going to grab the image format from our channel to our channel count to format, okay? And then we're going to go ahead and call image create on that, okay? All right. And in fact, we actually don't need this call up here anymore either, because we're doing that here or here. Okay. So that should be it for that. The next thing that we need to do is we actually need to create our two functions for our read data and read pixel. So this is going to go right above create geometry. So right here, and we'll quickly just go over this. So basically what this does is it grabs some information about the image format. It creates a staging buffer, binds it. It goes ahead and gets a command buffer set up, a temporary one. It transitions the layout from undefined to transfer source. It copies data from the image to the buffer, transitions it back from source to read-only optimal, and then ends. And then it goes ahead and performs a read to the out memory, and then unbinds and destroys the buffer. This read pixel does the exact same set of steps, except it basically calls image copy pixel to buffer. So it's pretty similar there. And so a couple of other minor changes that we need to make. So in the shader create, one thing that's a little bit weird about this function that's kind of been bothering me for a while is we actually have this shader type and shader identifier here that are named the same thing, which is not great. So I'm just going to rename this to S and apply that. Okay. And let me get rid of this. Okay. So that's just named S now, so that we don't confuse the type in the actual name of the variable. And then also we have this out shader, which is sort of a leftover of the way that we had this function set up before. I'm going to name this internal shader to be a little bit more representative of what it actually is. So I'll go ahead and perform that refactoring. And actually most of the changes throughout sort of the rest of this are around that. So I think that is actually all we need to do for that for right now. So let's see. So we have the shader initialize. We do need to kind of do the same thing to that. So once again, we have a little bit of a sort of naming conflict here. So we have shader again, but then we also have S for our internal shader. So I'm actually going to rename S in this case to internal shader and apply that. And then I'm going to rename shader to S and apply that. Okay. And that just should make it a little bit easier to understand what's going on in this function. Now, what is this bleating about? So this is the attributes, D-array length, too many arguments in function call. IntelliSense, I think you be tripping. So I'm just going to ignore that for right now. All right, let me just check my notes here and see if there's anything else I've missed. Oh, right. Okay. Actually, IntelliSense does not be tripping because this is the pipeline creation. So what I'm actually going to do is I'm going to go ahead and right above here, where we're actually calling that create, we need to create our configuration object. So I'll go ahead and set up the pipeline config there. This is going to be S. S. See, this is where that that shader name is kind of crappy. Whoops, why am I typing W? Should be. Let me try that again. S. S. I know these need to change. Did I get them all? Probably not. Shader flags. Right. All right. Anyway, so we have that, and then what we can do is take all of these parameters, get rid of them, and pass the address of pipeline config. And I think I can make this all one line. So let's do that. Clean that up a little bit. So now that's a little bit easier to understand what's going on there. And then a little bit further down in our acquire instance resources, we need to make some changes here as well. So right here where we're saying wipe out the memory for the entire array, even if it isn't all used, we are actually going to be changing this to be within a check to see if the instance count is greater than 0, because it is highly possible that we have a situation where there's a shader that has no instance textures. We are going to have that very soon. And in that case, that would actually cause this code to break. So we need to do a check to say, hey, we only want to run this if we actually have done anything with it in the first place, which would only happen if we have a texture count greater than 0. So that's just a little bit of bug there that we need to fix. Our render pass create, there we go. That needs to have its return type changed to a B8. And once again, we need to replace all of these parameters with just the config and the out render pass. We can get rid of these guys because they do not exist anymore. The depth and stencil are going to be the config arrow depth and config arrow stencil. And then I think basically this whole function is going to wind up changing. So we have notes in here to make a lot of this stuff configurable. And that is what we're going to do. So instead of actually just, sort of making all these assumptions about how many attachments we have and what the order of the attachments is, because we're saying the first attachment's always going to be color, the second attachment is always going to be depth if it exists. Like, we don't know that that's going to be the case. We don't want to sort of force our application to be that way. We want to be able to attach them in any order that we want. And so this was fine when we were getting things up and running, but it's not really going to fly sort of at this point. So I think what I'm going to do is, let me just flip over 1 second to another version of this file, because versus going through this and changing it section by section, which I think is going to actually take longer, I think it would be much quicker if I just actually replace replace the relevant section here. So let's see. So we're going to get the whole function here. So I'm just going to select the body of this. And most of the code here is actually going to be the same. It's just the way that this is set up is going to change. Okay, so let's review. So basically, we are going to set up the internal data of the render pass. We're going to cold cast it, set up the depth and stencil, set up the main subpass, and then we're going to create some D-arrays for all of our attachment descriptions. So this is all of our attachments attached in the order that they were attached. We're going to have a separate one for just the color attachment descriptions and a separate one for just the depth attachment descriptions. And then we're basically going to loop through the configuration's attachment count and then take a look at each attachment config, create a new description for that, and then take a look at the type. So if the type is color, we're going to say, well, are we going to be clearing this? And for that, we'll check the clear flags to see if the color buffer flag has been set. And then we'll take a look at the source next. So the source, if the source is default, meaning it should use sort of the default render attachment source for that. For color, we're going to use the swap chain image format. Otherwise, we're going to default to R8, G8, B8, A8 unorm. And I do have a configurable format to do here. We might be able to eventually maybe provide some sort of formatting to be used for the color attachment to be able to override this, which is why I put that there, but I didn't want to really implement that now. We can always come back and add that later if we need it. So for right now, I've hard-coded the samples to 1 bit. And then basically, we are going to determine what load operation to use. So if the load operation configuration is set to don't care, then the only other thing that needs to be checked is whether the attachment is being cleared. Because if it's being cleared, then that means that we are going to be loading it, right? Or sorry, we're going to be explicitly saying the load operation is clear. Otherwise, we're going to say we don't care, okay? So if we're clearing it, then we say, okay, we need to clear it, otherwise we don't care. If we are loading, right? So if the load operation is load operation load, and we're clearing it, then we're going to warn to say, hey, we're loading this, but we're also setting it to clear. This combination is invalid. It's going to go ahead and set it anyway to load op clear, but it's going to warn you about that just so that you know that it's like, hey, you've kind of messed up the configuration here. What are you doing? Otherwise, if it's not doing a clear, then it goes ahead and just loads. If it's any other sort of combination of this, it'll say any or invalid and unsupported combination of load operation. It'll give you that, the hex of that, and then the clear flags hex for the color attachment. And then, just sort of give you that and then say, hey, that's actually a failure. We're not going to allow that. And then we're going to determine which store operation to use. So if we have set that we don't care to store it, then we're literally just going to translate that directly to don't care. If we are saying that we do want to store it, then we're going to use VK attachment store up store. Anything else is going to bleat about it and print out the hex of what it is and say, hey, this is invalid for a depth attachment. Okay. So the stencil and stencil store op are going to be set to don't care because they're never going to be used on a color attachment. If we're loading, that means we're coming from another pass, meaning the format should be image layout color attachment optimal. And then we have some notes here. Otherwise, it is undefined. So we're basically setting the initial layout if we are loading to color attachment optimal, otherwise undefined, okay? And then if this is the last pass writing to this attachment, we should present after should be set to true. So this is up to the view itself to know whether or not it's the last sort of pass. before it actually gets presented. So like if the view knows that it's the last one before that image goes on to be presented, then that flag should definitely be set to true. In that case, it will transition the color attachment to a layout for presentation. Otherwise, it will leave it as a color attachment. And then, of course, we are zeroing out the flags because we're still not doing anything with that. And then we go ahead and we push it onto the color attachments array. So that is the color processing for the attachment. So it's very dynamic now. The next thing that we go ahead and check is the depth. And we do a lot of similar processing for depth, setting, checking flags, things of that nature. It's a little bit simpler than the color attachment, but yeah. The only other thing in here that I haven't taken care of yet is configurability for stencil attachments, because we're not using stencil attachments just yet. We will eventually, but for now, those are just hard-coded to don't care. So once it's all done with that, it goes ahead and pushes onto the depth attachment descriptions. And then either way, no matter what type of attachment it is, it pushes onto the general array. So it loops through all of those. And then it says, okay, the attachments added basically is how many attachment references we've created, okay? So we loop through each of the color attachments, create a attachment reference for that, and then we go ahead and increment the, attachments added so that we can keep this index here correct, okay? So we go ahead and set up the color attachment count and the p color attachments if we have attachments. If we don't, we set both those to 0. Same with depth attachment. Only the depth attachment basically says if the depth attachment count is already 1, right? So if we try to attach more than one depth attachment, it's not supported. And so we're only going to allow one depth attachment to be attached to a subpass. And remember, this isn't the actual view of the individual frames attachment. We're just talking formatting information here, right? And then we have pretty much all of this was the same as it was before. The only thing we've done is we've gone ahead and added some cleanup down here to destroy our attachment descriptions arrays, our references arrays, and that's pretty much it. And it returns true. Okay. So that is that. And let's see. So I think that might be it for the back end. Let me just double check my notes. But I think that is no, there are actually a couple more things, a couple small things. So render target create. You need to update this to use the instead of an array of pointers to textures, we just need an array of render target attachments, and then we change this to a B8 to indicate success or failure. Since we have that, we actually need to change this logic here a little bit. So basically what I'm going to do is we can actually get rid of all of this and just have our attachment views being set up to use basically the view from the texture's internal data at sub I, right? So we're basically going to go ahead and just get the attachment views, and then we're going to copy those attachment views, or the attachments rather, to the attachments here. So since we are dealing with render target attachments, this needs to be size of render target attachments times attachment count, not just size of texture. So we'll go ahead and fix that. There is another place in destroy where we're freeing this right here. That shouldn't be a texture pointer. That should just be size of render target attachment. Oh, that reminds me, that actually, this should be render target attachment, not a pointer. Right. Okay. All right, so that is that. What is next? Right, we need our window attachment get. So we're actually, since we have, since this is technically talking about the color attachment, I'm going to say attempting to get color attachment index out of range, okay? And then here, this is returning a texture pointer. These are no longer pointers, so we have to return the address of this to get a pointer. This here for the depth attachment now takes in a index, and so we're going to return the address of that. We should probably also copy this error message down here and say depth. Okay, because that's now going to line up. And this should be depth textures sub I. So we have that. Whoops, sub index, not sub I. Okay. And then we have our new method for the attachment count. So we have that here just being returned. And that, ladies and gentlemen, is it for the Vulkan renderer backend. So this is actually where a pretty big section of these changes is actually made. Now, we do have quite a lot left to do. So looking at the recording, it looks like we're about an hour and a half in. Let me see here. Yeah, I think this is probably a good place to stop. So what I'm going to do is I'm going to end this video here, and I'm going to create a basically a 77.5 video because this is video 77, and since this went on a little bit longer than I was thinking, it involves a little bit more changes than I was thinking, I think I'm going to go ahead and split this video here. So this is not going to compile or run in its current form. So when this code gets pushed, in fact, I probably am not going to actually push the code up to the repo until the next video comes out. And that'll be 77.5. And that will be, of course, next week. And I'm just going to do that simply because that video is probably going to be almost as long as this one, and just getting all of this stuff straightened out. So I'm going to go ahead and end this here. Thank you guys so much for watching. I appreciate you guys following along. I hope you're enjoying the series. I know this is a lot of work, but you know, it's definitely necessary to make things more configurable, and we're going to be heading more and more towards configurability and flexibility as we continue forward. So stay tuned for that. I will see you guys in the next one. That's about it. See ya.